Hello, folks. Welcome to Rational Science. How's everybody doing? I hope you're all doing fine. We're going to have a great day today. We're going to be talking about nothing again to some degree. It's a little boring subject when you talk about nothing. But no, we're going to talk about the gravity that pulls on nothing. Hey, that's even better. Anyways, before we get there, let's talk a little bit about extinction, which I think is kind of around the corner, at hand, so to speak. And then we're going to answer some questions that some people made, some comments that people made. And then we'll move on to the main course of the day, okay? Okay, so let's get started here. There was a little article, okay, about something I talked about the other day, which was the population of Russia. Just a quick comment on that. Says the Kremlin's top doctor this week encouraged all Russians to what? To engage in a sex at work scheme in a move to back Putin's attempts to counter a growing population crisis. And I guess they're going to all become sex workers now. They're trying to stimulate the production of children. And, I argued past many times that, no, that's impossible. You cannot get restarted the population, not of Russia, of the whole planet. We're not having children anywhere. Okay, so even countries that traditionally had lots of kids and are associated with high population rates, even they have cut their population at least in half since the 60s. So if a woman had maybe 7 children on the average, Nigeria in the 60s, well, in the same country now you would probably get 3 or 4 only. So the population increase the rate has dropped completely. And we can't recover from that. And again, it's funny that the Russians still haven't figured it out. They think they're going to bribe the women to have children, giving them some kind of perk if they have a child or whatever. It's not going to happen. It's not going to happen in great measure because everybody has moved to the cities, and you can't have children in the cities. There's cities are no place for children. Okay, so people are not going to have children in the city for several reasons that I covered in the past, and that's essentially the problem. And everybody lives in cities. They move from the country to the cities. When you were in the country, you needed children. There was a different culture, and now that culture and economy has changed completely. Anyways, that's talking about Russia, The issue there is also that we may be very close to extinction, like I always keep saying. I think it's going to happen this century, okay? Before the end of the century, I don't think we're going to see the 22nd century. It's probably going to happen before mid-century, before 2050, even before then, I think. But people say, Bill, you're such a pessimist. No, I drink beer, I drink wine, I drink whiskey also. I'm not a pessimist. I'm a realist. I'm just trying to tell you what I think is coming in our direction, okay? And part of the equation, economics, right, has to do with the fact that we have 3 empires on the planet today, almost 1.5, because the other 2 empires are kind of working together. 2.5, I meant, really not 3, because the other empires, the ones that are against the United States empire, the biggest empire that's ever been on Earth, they're working against the American empire, and they're holding it back. And right now there's like a momentous situation where, kind of like in the days of Lincoln, where, they had this election, and if Lincoln got elected, there was going to be civil war and everybody was going to kill each other, right? And there's a sense out there among the pundits that we've got that situation again where there might be a World War III if Kamala Harris gets elected, because she might follow the same policy of Biden. And on the other hand, you have Trump, and a lot of people say, well, if he gets elected, we can avoid World War III because, they reach a deal, and he's a businessman. He's going to do some horse trading, and we can avoid World War III. Well, I can only tell you my assessment on that, and I'm saying that it doesn't matter who gets elected. I think we're headed towards World War III anyways. And the reason is, empires need to expand. And the United States is having problems, economic problems, serious economic problems, and it needs to expand. And it finds these other mafias out there, mafia here, mafia there. They're all mafias, really. And they want to expand. They have to expand. If they don't expand, they die. They collapse. They kind of implode. And so, in order to avoid that implosion, they have to try to expand. And so, I don't think that either candidate who gets up there as president, I don't think anything's going to change. The United States is forced as an empire to expand, and it cannot avoid expanding. And that's why I think World War III is inevitable. They're going to look for whatever excuse. It doesn't really matter. And the point is that, nobody wins a world war with nuclear weapons. Once those weapons start flying, lots of people are going to die. But what's really going to die is the global economy. Okay? We can't recover from that. We're having problems right now. It's going to be much, much worse if they throw the bombs. We can't recover from a world war in which nuclear weapons are being thrown. And so this is the issue. The issue is whether we can avoid it. And I'm saying we can't. Just like we can't avoid not having children, we cannot avoid, a nuclear war, which is part of the economic expansion. So it's an economic problem ultimately. And, we can't fix the economic problem. The issue here is, long ago we abandoned the natural economy. What's the natural economy? Mother Nature's economy. And what is that? It's food. Okay? Food is the natural economy. And the way it works in the wild is someone hunts someone else. That's it. That's the way it works. And we abandoned that that style of living, that mode of living, long time ago. In the Neolithic, at least, you would say anywhere from 10 to 15,000 years ago, we went into farming and started planting. We stopped hunting, and we became, farmers at the time. And from there, we worked our way to the industrialization. We modified our economic system. And today we have an even more unreal economy, which is services. And within that, even worse, internet services. So we moved from manual services like, landscaping and maybe barbering to hands-on type of economic system where we just create things on the internet, and that's entertainment, commercials, ads, it's nothing real. And so, and that cannot continue forever. And there's no other line item we can move into from there onwards. We're done, so there's nothing else that we can do. We can't live for the next million years doing services, especially internet service, to each other. Okay? So, our economic system, I think, is going to collapse. World War III will just exacerbate that situation, and it's going to be all over. So it's not that I'm pessimistic, it's that I'm telling you realistically that's what I see. And all you can do is take that with a grain of salt, with a pinch of salt, and reach your own conclusions. Okay, and talking about extinction, a little article that came out the other day got me started. This was an older article that puts it in the right context. Here it is. Okay. It says, curiously, while we have ample evidence of Neanderthal DNA in humans, we have yet to find an example of modern human DNA in Neanderthals. Okay. And this came out in 2024, this year really, but it's an old, we've known this for a long time, that Neanderthals don't have any human DNA. Okay, and they try to look for reasons, etc., right? They're trying to justify that. But there was an article this week and says the opposite. They reach a different conclusion. How did they do it? Did they go and test a Neanderthal and measure him or anything? No. They went out there and looked at a few reports, put them together, and this is their conclusion. They said they did it on the basis of mathematics, okay, as always, right? And here it is. So a paper this week in Science concludes Neanderthals inherited as much as 10% of their genome from modern humans. And the way they did it is they took sub-Saharan Africans and data that they had from them, right? And they said, look, we're going to look for how much genetic variability they have. I mean, this is the present, right? And they looked at whether the Neanderthals had similar DNA, and they said they do. And so they concluded that they couldn't have gotten it from on their own. They had to get it from us somehow. And that's how they concluded that Neanderthals have up to 10% DNA. So it's a mathematical footwork there, that's all it is. And they're changing the policy. They have to find a way of showing that Neanderthals have our blood and we have Neanderthal blood, because they have no explanation for the extinction of the Neanderthals. And the way they look at it, we humans, right, we're responsible for all background extinctions. The dodo bird disappeared because we killed him. The thylacine, the Tasmanian tiger, he disappeared. Why? Because we killed him. And we killed everything. The passenger pigeon, the great auk, we killed them all. And they never thought that there could be another mechanism at work. Okay, and that's the issue. Did we kill all the mammoths and all the mastodons? We're responsible for all of them. And so when they look at Neanderthal, they say, well, how do we explain the disappearance of Neanderthal? Very simple. The original theories were that we killed them, we outcompeted them. Maybe it was the weather. You have all these weather guys. They say, well, it's the climate change, and they couldn't adapt. And then they finally said, no, we got it. Now we finally got it. They intermarried with us, and they were a smaller population, and they dissolved into a bigger population. And what happened was that they bequeathed to us some of their genes, up to 2%, 2 to 4%, they say. And because of that, we inherited maybe some defenses and some weaknesses from the Neanderthals, what they were, some of the diseases they were susceptible to, et cetera, et cetera. Okay, so that's the situation. And what happened was that, they created a cottage industry of how the Neanderthals disappeared and what kind of DNA we have from them and what kind of diseases. And there's a whole cottage industry on DNA. And a lot of people say, well, it's got to be true because, we get all these criminal cold cases that we can solve thanks to DNA. So people trust this DNA thingy quite a bit, And one thing is to apply it to cold cases that are 40, 50 years old. Another thing is to apply some of that reasoning to what happened 50,000 years ago in the Upper Paleolithic. And so all I can tell you, be very careful with the data out there. And one fellow wrote the following. He asked a question. He says, Neanderthal lived also in the Middle East and maybe India, not just Europe. We have DNA from the Middle East Neanderthals. Absolutely not. Okay. So that's the short answer. Let's go with the long answer here. Okay. First of all, here we have a couple of papers that were out there. I'm just going to mention two of them because there's a lot more, but just so that you know. Okay. Humans have no mitochondrial DNA from Neanderthal. Okay. Mitochondrial DNA is passed from females to the population, to their offsprings. So there's no human on Earth that has a Neanderthal mother that can prove or somehow, that there's any evidence that we have Neanderthal, that we ever had Neanderthal mothers, except the people at the Max Planck Institute. Their mothers were all Neanderthals. And I just wonder what cave they came out of, No human male has any Neanderthal Y chromosome, okay? And so we cannot show, no human male can prove that he ever had in his lineage a Neanderthal, some kind of Neanderthal out there that fathered him or fathered his father or his grandfather. Okay, so we have none of these two markers. Okay, no Y chromosomes and no mitochondrial DNA. Okay, we have none of that from the Neanderthals. And as I just said, we have no, the Neanderthals have not inherited any DNA from humans. And so they had to find a way of putting it together and say, well, yeah, maybe if we look at the sub-Saharan people and compare them with a Neanderthal, maybe we can do some fancy mathematical footwork and show that, we gave them some human DNA as well. So that's what they're up to. They're trying to prove it at all costs, okay, no matter what. Where all this started, really started like 40 years ago. You had people like Milford Wolpoff, Eric Trinkas, and these people are still around, by the way, John Hawkes, and all these people had no way of showing how the Neanderthals disappeared. So they said, hey, we can't prove it with climate change. We don't believe in that. We don't believe that humans outcompeted the Neanderthals because they had, very sophisticated weapons. The other guys came with slingshots, and we came with drones, so we exterminated them. So they didn't believe all that. And so they said, no, there was a much more humane way of making them disappear. And the way we did it is we married them. And boy, that's you tell me. So they started with this admixture, interbreeding theory. And it finally culminated with Svante Pääbo's paper in 2010. They did a genome on 3 Neanderthals, and they concluded that the Neanderthals have, that we inherited 2 to 4%. At the time, I think it was just 2 to 3, then they extended it a little more. 2 to 3% Neanderthal blood in us, DNA, right? And so did they prove it? Did they really show without a shadow of a doubt that we inherited that from the Neanderthals by intermarrying with them? And the answer is no. The answer is that there were other opinions out there, but those got flushed out. The idea that was put forward is that we all descended from the same Homo erectus a long time ago. And one Homo erectus went to the Arctic regions, really, Northern Europe. And the other stayed in Africa or traveled to Africa. And so we have these two populations developing differently. And after 500,000, 800,000 years, of course, we were left with still some amount of DNA. Well, they didn't like that theory because that did not show how the Neanderthals disappeared. And that was the big problem, okay? And so they had to introduce this admixture or interbreeding theory. And so this is the paper that Svante Pääbo put out there, the draft sequence of the Neanderthal genome. You can see Pääbo's name right at the bottom. He would win the Nobel Prize in 2022 as a result of really that. But what you got to know, there was a lot of politics involved with this. Because if you look at what happened, give me a second here. If you look at what happened in 2007, okay, Time Magazine named Pääbo as a very influential person among the 100 most influential persons on the planet, and they did so because he got. They gave him the responsibility at the Max Planck Institute of deciding, this thing about the genome. He was going to be in charge of the project. And so they said, when this guy comes out with something, it's going to be groundbreaking. And it turns out he did. He already had these ideas about, interbreeding. When he got to 2010, 3 years later, he comes out with the genome, says, hey, we've proven. At the time, it was just a suggestion, but he said, we've proven that, Neanderthals mated with us. Okay, and so his paper went out. It was a great success, and he created this new cottage industry, and because of that, they gave him the Nobel Prize. So it was all politics. It has nothing to do with science. This is what you find in the Wikipedia today. It says, Pääbo and his team also concluded that there was, Probably, right? Interbreeding between Neanderthals and Eurasians. And then there's mainstream support for the theory, and then it says that this admixture could have occurred roughly between 50 and 60,000 years ago. Well, it turns out that, a recent paper also modified that, and they say, look, really, now it's up to 200,000 years ago we made it, and then we did it again in 100,000 years ago. There was all these phases that they had to show, right? that we kept interbreeding with them every time we found them. And so at all costs, they're trying to prove interbreeding. Okay, so there's a lot of politics behind this, has really very little to do with science. Okay, so what did Pavel really say? And here are a couple of papers where and talks that he gave where I got this information from, so you can see what's happening here. Okay, the first one is that he compares Africans against non-Africans. Okay, here it goes. It says, if there was contribution from Neanderthals to Europeans, we would expect Europeans to share more genetic variants with Neanderthals than what Africans do, since there were never Neanderthals in Africa. Okay, now the important thing here that I want you to focus on is that he's comparing Africans versus non-Africans. Okay, so it's Africa versus the rest of the world. Okay, that's the way they put it even to this day, and they flush a lot of the important detail out. They take it out and they don't let the public know too much about that. Okay, what's the issue? The issue is what you find in his paper, in his original paper, and here it is. He talks about it in another talk. He says, had there been contribution from Neanderthals, I would expect it to be in Europe and nowhere else, because Neanderthals lived in Europe and Western Eurasia. But we found it also where? In China and even Papua New Guinea, where everyone is sure there had never been Neanderthals. What's the issue here? The issue is that they found more Neanderthal DNA in Papuans and American Indians than they found in Europeans. And so they had a problem there, because now you have to explain that as well. Okay, and here it is. Here's a paper talked about. It says, scientists finally solved the mystery of why Europeans have less Neanderthal DNA than East Asians. And they have less than East Asians, less than American Indians. And according to a report from India itself, not American Indians, but India, right? They say even Indians have more Neanderthal DNA than Europeans. And so the question is, how do you answer that? And not so much how do you answer that, why don't they publish that? Why does that come out? Instead of saying Africans versus non-Africans, they should say, look, we have Africans versus Europeans, but just in case, Papuans, American Indians, and Indians from India, right? They have more DNA, Neanderthal DNA, than Europeans. And so how do you explain that? I mean, that's what they should be saying. Instead, they say, look, Europeans have more than Africans. And so we have a problem there, because that's manipulation of the data. That's what it is. And that hasn't trickled very well to the public. Okay, that's the issue. Okay, so this theory is out there. And what does Pavel say in addition to that? He says the following. He says, the model we proposed, how did we get all this DNA, right? Is to say that when these modern humans, right, came out of Africa, they presumably passed by the Middle East, okay? They became Muslims, I guess, right? These early humans mixed with the Neanderthals and then went on to become the ancestors of everybody. We're outside of Africa. Yeah, it's outside of Africa, right? They have to show that they don't say how the Papuans got it, or were they also in the Middle East or what, So they have to say outside of Africa, and that's how we got it. We got it by going to the Middle East and mating with them there in Israel and Iraq, okay, supposedly in that region, because that's where they found some alleged Neanderthal bones, right? But what's the issue? The issue is that, and again, all these papers get flushed down the toilet. It's very hard to find them today, and if you're not aware, you don't even know about the issues. But here it is. Let's put it up there so that you can see. Here it is. This is a paper that they wrote, and this is not the only paper. They had other papers like this. There's actually little evidence for the existence of a Southwest Asiatic Neanderthal population in Israel during the Middle Paleolithic period. Human fossils originally labeled as Neanderthals were subsequently reevaluated and defined otherwise. A horizontal mandibular foramen, which characterizes, etc., the Neanderthals, is absent in, and they mention 3 sites. If you read the paper, they go off and say, in short, that what they have in the Middle East are not Neanderthals. Okay, those are not Neanderthals. If you compare the so-called Neanderthals of Shanidar Cave in Iraq, and you compare that against the classical Neanderthal, like, the original one in the Neanderthal Valley, and the ones in Spain and the ones in France, they're not the same. They have too many differences to say that this is a Neanderthal and that's a Neanderthal. It's very likely a different species altogether. That's probably what it is. Anyways, the deal is that no Neanderthal was in Middle East. That's my take on that. All I can tell you. And part of the reason is that Neanderthal was an Arctic creature. Remember the glaciers were all the way to northern England, northern France. They extended all the way down there, and that whole region was populated by Neanderthals, which were the offspring of Heidelbergs, which were the offsprings of antecessors, which were the offsprings of Homo erectus, which was the first fellow to go to Europe. We have footprints and evidence from bones that they found, woolly mammoth bones in that region, and it was some kind of human that killed that animal. And so we have evidence that in the days of Homo erectus, almost 1 million years ago, really closer to like 800,000 years ago, where Homo erectus, or some maybe antecessor, maybe Heidelberg, was already in the Arctic. And you say, how did he get there? Because we hadn't invented clothes. And so these people, these individuals, this species that was there, was nude, completely nude, in the Arctic. Okay, so keep that in mind. There's no clothes. And so they got adapted to the clothes little by little over thousands of years. They lived there for thousands of years. From that original seed, you get the Neanderthals hundreds of thousands years later. Neanderthal was completely adapted to the Arctic. He had no clothes, ever. They never invented clothes. Okay? Especially, we never found a needle. They had no needles. They had no use for needles because they didn't sew and they didn't put, furs around themselves like they're always shown. No, they were completely nude. And I picture them as very hairy. It was a woolly man. And he was in his habitat. He had no shoes. He stepped on the snow, on the ice, okay, with his feet, with his bare feet, okay, just so you know what we're talking about here, okay? And so, what this Svante Pabo did, he's brushed a lot of that, swept all that data under the rug, there he is. He brushed in the empty DNA, the Y chromosomes, the fact that the Asians and American Indians and so on, they had more DNA, more Neanderthal DNA than Europeans, which nobody can really explain. And nobody cares about that. Everybody just went into the cottage industry of saying, oh, let's see what diseases we have and how much DNA we have from the Neanderthals. And they went out to a lot of nonsense that has nothing at all to do with anything, especially not with the extinction of the Neanderthals. No, Neanderthals never mated with us, and it just shows that these people don't know even the basics of anthropology, because no animal mates in the wild. Two different species. They don't do that in the wild. Aside from the fact that we were separated from the Neanderthals for 500,000 years, we couldn't have had successful children from them. That's another issue. But the point is, when you're in the wild, the worst thing you can do is trust. There's no such thing as faith. Trust. Belief, all that comes later with humans. Many hundreds, thousands of years later. In the jungle, you don't trust anybody, okay? Because that's your enemy. That's that other animal there, he's out to kill you because he needs to eat. And that's the way it works. Neanderthal wouldn't trust a human. Neanderthal wouldn't trust another Neanderthal. Okay, so it's not like the clans got together, drank beer, and swapped wives. No, it didn't work that way. There could have been kidnapping. There could have been other ways where they met and they mingled and had children and created their own clans. That, yeah. But clans did not trust the neighboring clan. They all protected their own territory. They probably marked their territory by pissing or shitting around the block, you know. You had to mark your territory. This is my hunting ground, bud. You know, you get out of here. You're not part of our clan. That's the way it worked. And if humans ventured in there, they would have been slaughtered, okay? Because you have a small pack of humans moving into Neanderthal territory. They're not only on their own ground, you know, they're on their own territory. They wore no clothes. The other guys had to put something on because they were freezing to death, so it's humans who invented clothes, and they would have been slaughtered. And that would explain why humans were already in China way before they got to Europe. And you say, how can that possibly be? Europe is, you know, just a little north of Africa, and Asia is on the other side. Well, I think that humans did venture into Europe, but they got slaughtered. That's what happened. And it's only when the Neanderthals imploded, when their own population imploded, that's when we could enter Europe. And yeah, I'm sure that they went into caves and found, you know, skeletons. Who the hell is this guy? You know, and it was a Neanderthal that had died a long time ago. You know, there was no mating, no such monster. Anyways, here's a summary on some of that. It involves this fellow, Svante Pavo. He's an idiot. Okay, he's an individual with big ideas. You know, that's what an idiot is. And yeah, we have no empty DNA, no mitochondrial DNA. We have no Y chromosomes. And we have no, and Neanderthals have no human DNA. You know, and again, we, you know, different species don't mate in the wild. And the question is whether we were the same species or two different races, right? Because you know, you take two dogs, you take a Doberman and you take a Chihuahua, and they'll mate because they're the same species. They're just two different races. And the question is whether we were like that together with our long lost cousins, the Neanderthals, or whether we were two different species after, you know, 500, 600,000 years of not seeing each other. You know, were we the same even species? Could we have mated, have viable children, right? Then you got all these problems that I mentioned, and you can see it in my series there where I talk about admixture. Look it up in my channel. But you have the issue of shouting distance. You know, no one could venture too far away from the clan in any of those, whether it's human or Neanderthal. They could not venture too far because you don't know what kind of animal can get you out there, let alone, you know, saying that they had a one-night stand, you know, with another species, you know. We found no half-breeds. These people talk about trade, that we traded seashells for furs or who knows what, you know. Trade was not invented at least until the Neolithic. And for these people to talk about trade in the upper Paleolithic, these people really have mental problems. Then you have the question of looks. And I think that's an important one. Let me show you what I'm talking about. I'm talking about this. This is a Neanderthal compared to us. Look at the skulls, okay? And you can see that they're a little bit different. And they have an elongated skull in the back. They have heavy brows, which we don't have. Big noses, right? Ours is a tiny little nose. They have big noses. And above all, they had no chin. And we have chin. We're the only animal that has chins, okay? Says another thing that is very distinct in Homo sapiens is the fact that we do have a chin. This protuberance here is very unique to Homo sapiens and is absent completely from the mandible of Neanderthals. And here, just in case, let me show you more evidence on that. Here it is. One site for geology says, no, really, other animals don't have chins. Okay, that's correct. We are the only animals on Earth with true chins. Even our extinct relatives, Homo erectus, as well as chimpanzees and gorillas, do not have chins. And you can see there, the chin is not there. Ours is pointed outwards, whereas all theirs are pointed inwards. So you can see that Neanderthal was a little different than us. You know, we didn't really look like them. Okay, and so for these people to say that we mated with this monkey, right? You know, it's a little far-fetched. So just for your own sake, take all these things with a grain of salt, right? And then what's the issue? The issue is also clothes. You can imagine us coming with clothes. Here's how Neanderthal evolved in the 20th century. He evolved more in the 20th century than the upper Paleolithic. here he is. You know, this was the 1909 original Neanderthal, and look how he changed over the years. Man, talk about evolution. Yeah, they had to make him more white, okay, less monkey-like. They had to make him less furry, right, over time. And just in case, you know, eventually they ended up dressing him with clothes. But you can see that their thorax was quite different than ours. Their heads were different than us. You know, these were monkeys. These were just some kind of monkey, a furry monkey that lived in the Arctic that evolved from Homo erectus ultimately. And it's funny here, you can see they dress them up with clothes today. And you say, where did they get the clothes? Did they go to a store or what? You know, they had some caves that sold them or what? You know, I mean. So this is part of the problem, okay? And again, Svante was listed in Time magazine, you know, as an influential person. And why was he important? Why? Because the paleontologists, they had no ideas how Neanderthal disappeared, and they had to find a way of, of getting an answer to that question. And the way they said, and what's survived until today, is that we mated with them. That's it. And that probably turned into a fact. The Svante Pabo was probably turned into a fact. And just in case, they gave him the Nobel to certify knowledge. You know, that's the way you certify knowledge these days. You give them a Nobel Prize, and then it probably becomes a fact. No longer probably, probable or whatever. Yeah, so this is the situation. The situation is that all these people have created this cottage industry, and everybody's benefiting from it. Does it have anything to do with science? I call it political science. That's what it is, political science. It's got to do only with politics, with getting people to think about nonsense, about, you know, mating between a monkey and a human and stuff like that. It's got nothing to do with what really happened. You know, here you're talking about a different animal, different species altogether, evolved in the Arctic. We came out of Africa. We invented clothes around the same time, coincidentally, while we were moving into Neanderthal territory, Arctic territory. We needed clothes, so we started stitching maybe, you know, some furs together. And when Neanderthal saw this creature all dressed up with clothes, he must have ran the other way. He said, what the hell is that? A clothed human? What the hell is that? So, no, there was no mating. This has only to do with politics. We call it political science. Okay, let's go with some of the questions, comments that people made since last time. Here's one fellow, and he says the following. He says, a shape is flat and is limited to 2 dimensions. Forms are objects with 3 dimensions. That's the notion people have, right? A painting would be an example of shape. A sculpture would be an example of form. Okay, we understand what he's saying. Does that have anything to do with the definition of the word object? You know, an object is that which has shape, not that which has form, because you could say form if you want, but shape and form are synonyms in physics, okay, for the purposes of the definition of object. And why? Well, this is what I answered, okay? Let me get it up. Hold it. There we go. In German and in Spanish, at least 2 languages that, you know, I'm familiar with, they have no word for shape. It's all form, okay? So there is no word for shape. That's the first issue. But shape and form are the same thing. It doesn't matter if it's 3D or 2D, because any 3D form has shape. So shape covers 3D and 2D because all 3D forms have shape. That's the main one. If we limit it to form and we talk only about form, then we have a problem, because that excludes all 2D shapes, right? Meaning that a square has shape, but it's not an object. And yeah, a square is an object. It's a thing, okay? Why? Because it's different than that which doesn't have shape, like energy, field, force, charge. Those things don't have shape. They're concepts. They're mathematical concepts. And so we need to distinguish what mathematical physics has said for the last 400 years, that, they move concepts around, especially in the last 100 years. And no, we don't move concepts in physics. And so we had to use the word shape, not the word form. Forms also have shapes, so it's not a big deal anyways. And so we use the word shape. Okay, so just so people know where we're coming from with the language. We have to get the language straight. We didn't use the word form to define the word object, and which is critical because you can't do physics without objects. You need to establish the foundations of physics, which are the definitions without which you can't do physics, meaning the word object, the word distance, location, exist, motion, right? And you need to know what a concept is. You need to know what space is. We're going to talk a little bit about space today. Okay, and here, continuing with that line of questioning or commenting, here's a fellow says, concept, an abstract idea, a general notion. And I guess he gets this from the Wikipedia or some other source because that's what you'll find in the dictionaries out there. Yeah, the problem is that idea and notion, you can see the definitions there. What's an idea? A concept. And what's a notion? A concept. So what did we learn? We learned nothing. Concept is an idea. And what's an idea? A concept. And what is a notion? It's an idea. An idea is a notion is a concept. And what is a concept? It's a notion. So we've learned nothing. All that we have is circular definitions, which is what a synonym or an antonym for that matter is. That's all they are. They are, redundant. It's a circular argument. And so you can't use the word idea or the word notion to define the word concept, okay? So how do we define it? Well, let's see if we can get it here. Here it is. This is our definition. Concept, a word that invokes or embodies two objects or concepts that are treated as objects. Like space is treated as an object when you talk about, for example, the word universe. Universe involves matter and space, and both matter and space are concepts. So you have two concepts, but you're treating them as two different things, okay? And you're comparing them or contrasting or whatever. And so that's what a concept is, a word that invokes two objects or two concepts that are treated as objects, okay? Okay, and let's go with another question here. A fellow said, give me a second here. It has to do with the word exist. It says the following. It says, exist, to be perceived, to be conceptualized. Existence, the sum total of all that is perceived. So they think that exist has to do with seeing and touching, with our senses. And Ayn Rand was famous for having the same irrational definition. That something exists which one perceives. And that one exists possessing consciousness. In other words, she thought it had to do with the senses, with you thinking, with you believing, with you touching, with you sensing something out there and saying that's what exists. Well, we can touch or see or imagine or whatever. And no, she had an irrational notion of what the word exist is. We've always had irrational notions of what exist is. And that's why to this day you have atheists, agnostics and theists all going around in circles talking about whether you believe in God or whether you don't believe in God, whether God exists or whether God doesn't exist or maybe he exists, perhaps. No, it's not an issue of opinion. It's a question of definitions. Once you define the word exist, if God meets the specification, God exists by definition. And so we have to define the word exist. Here it is, okay? We show why God, if God wants to exist, what he's got to do. Exists physical presence, okay? There has to be an object. In this case, God has to be an object. God cannot be a concept like love or intelligence or something like that. And the object has to have location. What do we mean by that? Well, there's got to be a straight line of direction between God's index finger and my nose, okay? There's got to be a distance there, separation. And if there's separation, he's got location. If we are the only two objects in the universe, and then he exists by definition because he meets the definition of exist. So does God exist or not? Well, it's not an issue of opinion. It's an issue of assumption. If you are the person giving the presentation, you have to say, let us assume that God exists. Good, okay, we can see the assumption. What's your theory? Then you explain your theory based on that assumption. Then you can continue. That's the way the scientific method works, okay? It doesn't say, oh, God exists, I want to shove it down your throat, you better believe it, or I'll torture you. I don't think it works that way, okay? Yeah. Okay, here we have another following. He says the following. He says, a shadow has shape. By your definition, it's an object. And another fellow brought it up this week also says, are shadows made of atoms? Okay, so let's find out what shadows are made of. They're made of ropes. Okay, there you see all these little lines there. You have the sun somewhere out there and it's pointed at the tree, and what you have is the ropes connecting every single atom of the tree to the atom in the ground. Okay, so if you want to say what are shadows made of, they're made of light. What is light is mediated by ropes, so you can say a shadow's made of ropes. Okay, that's just poetry. Okay, let's see what the answer really is. This is the answer. Okay, let me get rid of this in here. The answer is that give me a second here. There. Okay, whatever. There is no standalone object called shadow. Okay, shadow is a concept. Shadow means blocked light. That's what it means. Okay, and it can be penumbra, umbra, whatever. But it's just a lack of pure light, you could say. Okay, the word shadow necessarily implies and invokes an object that blocks light. Okay, and there you see the shadow in the cube on Earth. When you take it to outer space, suddenly the shadow disappeared. The cube is still there because it's a standalone object, but the shadow is no longer there. Okay, and so just keep that in mind. Okay, shadow concept. Shadows don't have standalone shape. That's why it's a concept. Okay, give me a second here. Okay. Okay, and final issue, someone talks about this, which I really don't understand what he's talking about. He says, how rope theory, not a rope theory, it's called thread theory. Rope is a hypothesis that we use for that. Solved the problem of objects moving at the relativistic speeds. If no object is allowed to travel faster than the speed of light. If space doesn't stretch, then what else? Well, this person has been influenced, I call it brainwashing, influenced by the relativists. And they talk about relativistic speeds. What is that nonsense? What is relativistic speed? Well, it says speeds close to the speed of light. No object travels even close to the speed of light. But they postulate these things. They want to do a lot of math. And it comes down to this factor called the Lorentz factor these days, which is the 1 minus v squared over c squared. Essentially, that's that little piece of the Lorentz factor. That's what does the whole trick. If v squared, if the velocity of the object approaches that of the speed of light, you get 1, right? Because you would have c squared over c squared. That's 1. 1 minus 1 is 0. Square root of 0, guess what? You got a problem there. And they call that the laws of physics, the laws of mathematics break down there at infinity, at the division by 0. So, this is where they get this nonsense about traveling at the speed of light. No object can travel at the speed of light, period. That's what it is. And so I don't know what you're talking about when you say relativistic speeds. There's no such monster in our universe. The only fella who can travel at the speed of light is light itself, and it doesn't travel anywhere. It's a rope that torques in situ, okay? That's what it does, torques, and, nothing moved from this finger to this finger over here. What you get is you could say a signal that just propagated along the rope. That's all it is. And so there's no such thing as an object traveling close to the speed of light, even close to it, let alone at the speed of light, as good old Einstein told us. Okay, so no, there is no relativistic speed. It's just nonsense that created by the general relativist mathematicians who play around with these numbers and say, well, what if we travel at the speed of light? What would happen? And they put it in their equation. They say, well, the energy would be infinite and mass would be infinite, so an object can't travel at that speed because otherwise the laws of math break down at the singularity or something like that. Okay, so don't pay attention to relativistic speeds. That's just selling you some relativity garbage. so that you will believe it. Okay, that's all it is. That's good for mathematicians, but don't bring it into physics. Keep your relativistic speech to yourself. Okay, so now we have, let's move on to the main course of the day. Okay, and what is that? Well, we're going to talk about a little bit of nothing. Okay, so if you like to talk about nothing, hey, this is the place. Now we're going to talk about gravity, okay, and how gravity has entered the picture of the universe and the picture of nothing, and the picture also of what I covered the last couple of weeks, which is not only nothing, the space, but also what's outside of nothing, what encapsulates nothing. What object can you imagine that can encapsulate nothing? Okay, so we have nothing, which we have no definition of. We have no notion of what could be encapsulating nothing, against which nothing is pushing, right? And then we have the issue of gravity itself, because, under general relativity today, we have dark matter, which is gravity pulling, right? And you have dark energy, which is trying to break it up, pushing outwards. And so you have push against pull. You have dark matter or whatever other objects are in the universe that are pulling against dark energy, which is pushing outwards. And we're going to be looking at that. What is this thingy called gravity? I mean, how does it work? That's what we got to figure out. And we'll find out that we've got more than one notion of what this really is, okay? So here, let's start with this. The fact that, like we covered the other day, we have no definition for what space is. What is space? I mean, if it's a what, how do you define the word space? That's the issue, okay? If it's a concept, define it. If it's an object, point to it. That's the bottom line. And so this is where we stand here. You have a couple of fellows, last time, tried to define space. One say, look, it's an expanse, an empty expanse, largely empty expanse. And you look up expanse, and it's an uninterrupted space. Right, so we didn't learn much. Then another fellow said it's zero-dimensional as a three-dimensional continuum, whatever that means, a zero-dimensional, three-dimensional. But the key word is continuum. You look up continuum, it's a continuous extent. And an extent is what? A bunch of space, again. So we're back to square one. We have no idea. And, these are not valid definitions. They're irrational definitions. You can't use them. And so these people pick them up primarily out of Wikipedia or dictionaries or sources like that, and they make no sense whatsoever. No one ever really defined what space is. That's where the problem starts. And here you have the space recap. What I covered the last couple of weeks. And it says mathematical physics, they only have irrational definitions, especially for space. Okay, and that's been a serious problem now for 2,500 years at least, since the days of the Greeks. Okay, and if you look it up again, space, unlimited expanse, according to dictionary.com. What's an expanse? Uninterrupted space. Or extent. They use these words, extent, expanse, and they don't know what they're saying. Continuum, again, quantitative transitions without abrupt changes. That's what it is. And you look it up, and you find out the continuum is, this 3D continuum. They find it in the Wikipedia. So again, you can't use the words expanse, extent, or continuum to define the word space, because when you look up those words, it just says it's space. We're back to square one. We don't know what space is. Our definition, that which has no shape. Now that's a crisp definition you can take to the bank. Why? It's an antonym of the other word that we need to define the word universe, which is the word object, which is that which has no shape, which is that which has shape. So we have that which has no shape against that which has shape, okay? And now we can define the word universe and say universe consists of space, that which has no shape, and matter, all those things that have shape, the bunch of them, the whole of them, okay? The aggregate of them. All objects have shape 2D, not all objects have form, okay? So remember, we use the word shape, not the word form, because that tends to confuse people. Since all 3D forms have shape, all we need is the word shape and we're done, okay? We cover all the bases that way. If we said an object is that which has form, Well, we have a little bit of problem in English, not in Spanish or in German, for example, because they use the word form for everything. They don't have a word for shape for 2D forms, right? They only have the word form. But in English, you would have a problem because people associate the word shape with 2D and form with 3D. And so by using the word shape, you cover all the bases. We're done. You know, anything that has shape is an object. Anything that doesn't is a concept, essentially, okay? And a lot of that came from this fellow. His name is Aristotle, and they had the wrong notion. They started out with the wrong notion of what continuous means, you know, continuum, right? And he defined it as that which is divisible. Essentially, that's what he said. You know, he says the continuous is divisible ad infinitum, okay? And so if you look up his book 1 in physics from Aristotle, you'll find that in there, okay? And today we have these notions that continuous is that which is contiguous to something. You have all these pieces, again, divisible. And that's not what it is in physics. In physics, it's that which is made of a single piece. That's what a continuous object is. We treat the table as if it's not made out of atoms. It's made out of the whole shape, you know, it's made out of a single piece. All objects are made out of a single piece in physics, okay? And and then they talk about continuous functions, you know, and so that's a different notion altogether. It has nothing to do with physics. And that's the problem when they bring these notions of math and they bring them into physics. That's where we run into a lot of trouble. Okay, so that's for space. We don't know what it is, at least from mathematical physics point of view, but they use this word space, okay? And what is it? The space is simply, you know, this extent, this thingy, whatever it is, and they treat it as a thing for all purposes, but then they tell you it's infinite at the same time. You know, they say, oh, space is infinite. And so if it's infinite, it's not a thing because there's no such thing that is infinite, and it can't be infinite because you have the explosion known as the Big Bang. I hate to call it an explosion. Some people will want to crucify me for saying that. It's not an explosion, Bill, okay? So this thing exploded, the singularity exploded, it expanded, whatever you want to call it, expanded, and what does it expand up against? If the singularity Big Bang, includes space and matter. It includes space. So if space is in there, what's outside of space? It's pushing against whatever is outside of space. You know, you can't say, oh, it's pushing against space or empty space or what surrounds it, what gives it contour is space. And they always draw this black thingy, and we don't know what that black thingy is, and it looks like space to me, you know. And so they're only showing matter blowing up like a hand grenade, but it's always space. Inside the matter and outside the matter, it's always space. So we got a real problem there because we don't know what encapsulates space. But here we have it. It's called dark energy that's pushing everything outwards. I guess that dark energy is the space thingy that they're talking about. And so here you have it. What encapsulates space that we talked about last week. What is Big Bang pushing up against? That's the first issue you want to answer. If you can't answer that question, you can't even start your presentation because you don't have a definition. You can't even start. You haven't set the scenario, the assumptions for your theory. What is dark energy pushing against or displacing? Because if this thing is expanding, as you see it there, and you can see the whole glass, that's horizontal glass there, you know, it's got beer in it, I think. It's a fixed shape. They always draw it as a fixed shape. And so I need to know what the black stuff that surrounds, that gives shape to that glass is, okay? And if you can't identify the black stuff, you can't even start your presentation. So this is where we don't know how to start this thing because they never answer these questions. They avoid them completely, and they say space is infinite. Don't bother me anymore. You know, so that's how they answer. Then you have the problem with the multiverse and parallel universes. You know, they want their cake and they want to eat it as well. And here it is. They have these parallel universes, multiverses. And the question is, what's the black stuff, okay, in the multiverse? And the other one is somewhat light blue there. What separates one universe from another? That's what we want to know, because if space is inside the balls, right? Matter and space are inside the balls. That's what a universe is. What's the black stuff that separates one universe from another? And of course, they can never define it. Okay, that's the issue. They can never define what the black stuff is. They put it there, they paint it there, they illustrate it there, and nobody asks the question, what's the black stuff? You know, and that's the key question, because if you can't identify the black stuff, you can't talk about multiverse or parallel universes. That's how simple it is. Okay, so that's the question you got to ask these guys. Then you have the string theorists, they talk about hidden dimensions. Okay, 4th, 10th, the 26th dimension. They just put it out of your reach. That's what they do. They say it's beyond comprehension, beyond your questioning. You can't even question. And so that's how they do it. They say it's infinite. It's in the 4th dimension and 5th dimension. We cannot conceptualize it. Don't ask anymore. Okay. And when all that fails, they say, well, space is infinite, you know, and how do they explain infinity or finiteness? And here it is. Here we have our guru, good old Stephen Hawking, right? And what does he say? Well, he says the following. He says, finite, you know, we say the universe is not infinite in space, but neither does space have any boundary. And that sounds like a contradiction. It's not only that it sounds, it is a contradiction. Okay, we have a problem there because these people run into this wall and they try to BS you saying, look, it's infinite, but it's also finite. Okay, so on the one hand, he says it's not infinite in space, meaning it's finite, right? And then he says, but it doesn't have a boundary, meaning it is infinite. But they're talking about two different things. When Hawking says this, he's saying, look, the Earth is finite because we got a surface all around, right? And what continues is space, right? That black stuff there. Okay, so we all understand that. But when they talk about the not having a boundary, unbounded as they call it, they're talking about something else. They're talking about walking incessantly around the universe or around whatever object they're referring to. So yeah, a ball is finite, but running around it is incessant because if it's a smooth ball, you don't find a fence. That's what they're saying. And these are two different notions. So to say that the universe is both finite and infinite is a contradiction because they're talking about two different, or in other words, they justify it by talking about two different things. Keep that in mind when these people talk because they pull the wool over your eyes, you know, with it. Okay, so here we have Big Bang and we have push versus pull. We have the Big Bang there, okay, it's exploding, right? And what does all that matter pushing up against, especially including the space? Because remember, the Big Bang includes space inside it. And they call this dark energy, the stuff that's floating outwards. What we got to find out is what that is pushing up against. Because essentially what they're having is they have a push, which is the dark energy, and the pull, which is dark matter and all the visible matter. That's pulling, okay? So gravity is a pull. And you could say that anti-gravity, this dark energy, is a push. They haven't defined what this dark energy is, which is almost like 70% of the universe, right? They say it's a measure of their ignorance, and I think they came up short. I think measure of their ignorance is like 150%, okay? And so we have this in the realm of general relativity, okay? But what do we have in quantum? We have something totally different for gravity, right? They don't have dark matter or other kinds of big matter like stars and planets and galaxies pulling. They're a little more modest. They have to talk about these little subatomic things, right? And in there, they created the graviton, a particle that is supposed to pull. How you can conceptualize that, I have no idea. You know, here you have a ball, right? And imagine this is the particle. And I don't care how many particles of these you have. I'll give you a whole sandbox, you know, if you want. How do you pull with this? I mean, we can all understand push. It can come up against my skin. We can say push. Okay, I understand that. You know, particle is pushing on my hand. Now, how does a particle pull on my hand? Now, that's tricky. Okay? Yeah, it requires a lot of imagination to prove that one. And so the way they do it mathematically. And here it is. Here's the mechanism, okay? This is not gravity, but it's the same action at a distance mechanism, okay? And here you have the gluons pulling on quarks. This is the way it works, okay? You want to pull out a quark? Well, you send a gluon, and somehow it creates what is known as negative momentum transfer, okay? It throws a particle and it pulls the other quark in. And you can imagine those two quarks as objects, as two particles or two planets, whatever you want to put in there, it doesn't matter. What they're saying is you're sending these particles outwards, like the gluon there. You're sending the particles out, the graviton, okay? And somehow it pulls the other object inwards. And yeah, we can illustrate it, but it's unimaginable how this thing works in real life, okay? You cannot imagine. And so, yeah, we're dead. We're stuck here because we cannot get beyond it. This is an irrational mechanism. And they just illustrate and say, look, it is so. Please believe us because that's what we proved in the lab. And take it or leave it. But even if we concede it, let's concede it. Let's go out of our way and concede it. What does that have to do with this, dark energy that's pushing everything outwards? And you have the pull of gravity, matter, and dark matter, and all this other, and black holes and so on, wormhole. All this stuff is pulling stuff inwards. So, okay, so one is gravitons, the other guy is, mass that's pulling on dark energy, on whatever's pushing us outwards. They're two different mechanisms. Both of them you cannot imagine them, and they don't try to imagine them, they just say it is so. And so you have to believe on the basis of faith. Okay, that's how it works. And so we have a gentleman, his name is Arvin Ash, and he's going to illustrate for us what the mechanism of quantum gravity is, this graviton thingy. And the way he does it, and the way we're all moving in quantum mechanics, is we're abandoning quantum. We brought the word mechanics and forgot about the word quantum, okay? Because now they're going to have a field. It's a field day, right? And what is a field? Well, the field is whatever. It's a bunch of numbers. That's what a field is. It's reduced in strength as you get farther away from ground zero. Okay, so you whatever point you pick, you have all these numbers, these values, and they get weaker and weaker the farther away you get from that point. That's what a field is in mathematics. Faraday saw it as a region where something happens that he could not identify. And so they kind of mix these two together and say, well, it's a field and there's a region and we have all these values in there and they treat it as a physical object. Somehow the math becomes physics. That's where the problem is. And so what this fellow Arvin is going to say, look, we have these fields and we're going to exchange a graviton. Exchange a graviton. How do you do that? And let me tell you what the first problem is. The first problem is that he says that a particle is a vibration of the field, a local vibration of the field. So if you have the field, whatever the field is, all these numbers, right? They're vibrating, but locally they vibrate and they create these little peninsulas. They're not islands like a ball. This is an island, it's completely surrounded all around by air and ultimately by space. That's not what they're talking about. They're talking about a peninsula. It's a protrusion out of the field, local vibration of the field, but it's still stuck to the field, so it's a peninsula and not an island. Keep that in mind. But somehow he's going to get a little particle that floats between two fields. He's going to call it a graviton. I don't know how he got loose from its field. That's one issue. The other issue, he's going to liken it to a photon. And he says a photon is the one that mediates the electromagnetic attraction. Okay? And so an exchange of photons, little particles, discrete particles, which is also part of a field apparently, an exchange of photons brings two things together that are of opposite charges. Well, there's no such thing as opposite charges in mass, in the fields that he's going to bring together. We're not talking about charges here. It's just they all have the same charge, but somehow he's going to send this graviton back and forward, and somehow that brings the two objects together. He doesn't explain the mechanism. But listen to him. It's a lot of fun just listening to these guys because they think they know something about something and they know nothing about nothing. And here it is.
One can attempt to treat gravity as a field analogous to the electromagnetic field. An excitation in this gravitational field would be the graviton, just like an excitation in the electromagnetic field is the photon. The exchange of gravitons between two particles would result in attraction. This is analogous to the way an exchange of photons results in electromagnetic attraction between two oppositely charged particles.
So, did you understand the mechanism? Can you repeat it to me? How does the graviton do it? See, in the case of the electromagnetic fields, right? They have this photon going back and forth. One's positive, the other one's negative. But that's not what he said for the masses. He said there's an exchange of graviton, and it's kind of like, the photon. That's it. So I don't know how he does it even with a photon, let alone the graviton. Okay, so that's the gravity version of quantum mechanics. Now you know it all. Now you can get your diploma as soon as you pass the test on Friday. Okay, how do we do it in general relativity? Well, a little differently here. This is the version of general relativity. What they have is warp number lines, okay? All those lines that you see there, right, the green ones, those are number lines. They're not even dimensions or coordinates or vectors. What they are is number lines. And they're bending the number lines. Why? Because they're talking math. They're not talking physics, but they turn their math into physics, and they say, we're going to bend the number lines. That explains why the Earth there, the little guy there, right, little ball, doesn't fly out of the solar system. It's caught in this depression like, a ball rolling around a funnel, right? And it doesn't fly away. That's the mechanism. So we have these two mechanisms. One's the graviton that brings two fields together, fields of mass, I guess. And then we have the warp number line version. Okay, so you take your pick, which one you like most. And so just in case we ask one of the celebrities that we have today, which is Neil Tyson deGrasse. Good old deGrasse is going to tell us what gravity is. So listen carefully to his explanation for the gravity that involves general relativity. Here it is, okay? Listen.
Science can describe how gravity works, but can they describe why it works? So this is the how-why duality here. In science, if we can describe how something works and predict its future behavior, we claim to understand it and we move on. There's a point where it's not especially productive to continue to think about the world that way. When you understand the how enough, are tantamount to having answered the why question. I can describe what gravity is doing. I even have a mechanism for it. Gravity really is the curvature of space and time. Movement of matter on that fabric of space and time we call gravity. Why does matter and energy curve the fabric of space and time? And I don't have an answer for that. Why does matter and energy curve space and time? Okay, that's a frontier. We're still working on that.
Yeah, they've been working on that for 2,500 years at least. They're still working on it, okay? So, what's the issue? The issue is that we don't know why this spoon, right, falls to the ground. Okay, why it falls downwards. But they're working on it. I mean, it's so complicated, what do we have here? A spoon and the earth, essentially, right? And it falls downwards, and no one can explain the mechanism. And so the question is, how many more centuries, how many more thousands of years do we need to answer that simple question? And after saying all that, good old Neil says something else. He kind of gives us the punchline. This is from his show, which is Star Talk. And listen to him. Here he's going to tell us the punchline. Okay, listen carefully.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, what it is, I don't know. I don't know. I don't know. I don't know. What it is, I don't know.
So there you have an answer. They don't know. They don't know. I don't know. I don't know. That's the answer. That's how, first they tell you they know, it's the warping of space, then they say, I don't know. Okay, what is it that we need to answer regarding gravity? Very simple. I mean, here I told you, right? You have to tell me what causes the spoon to fall to the floor. Very difficult thing, I mean, Jesus. Just a little spoon in the earth, that's all it is, and it goes down, and nobody can answer that question. How can it be so difficult? Well, here, let's get another professor. He's from Berkeley, and he's going to give us the specification. What you need to understand, what you need to answer. Okay, he's going to tell you what we need to answer regarding gravity. Here it is. Listen carefully.
If you have the Earth with its big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. You're pulling on atoms right now on the other side of the Earth. There's a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
So what is gravity, or what is the specification? What is it that we have to answer? We have to answer how every atom, right? Every atom of the spoon is pulling on every atom of the earth. That's what we have to show, okay? That's what we have to explain, how that's possible. Well, the only way it's possible is if every atom on the spoon is connected to every atom on the earth, then every atom on the earth can pull on every atom of the spoon, and every atom of the spoon can pull on every atom of the earth. Okay, very simple stuff, really. Means that every atom of the universe has to be physically connected to every atom of the earth and vice versa. That's what it means. That's the only way you can explain that. And the only way it can be connected is through some kind of elongated object. For example, a rope, right? Not as big as this one. No, it's got to be something unimaginably thin, and it's long. It stretches from one atom of the spoon to one atom of the earth. You take your pick, whichever atom you want, okay? And so here's a summary of what good old Professor Muller talked about. Says again, what you have to explain is how one atom can pull on another atom. And the only way you can answer that is with an elongated object. There you have the link at the bottom. Just look it up and you'll find his own words there, okay? There's the YouTube video. Okay, so we need an elongated object connecting any two atoms to talk about gravity. Period. We're done. That's it. No warp space, no graviton flying back and forth, none of that. Okay, so how do we explain it? Well, here it is. This is the assumption. And once you have the assumption, it all falls in place. It's very easy. There it is. All the atoms in the universe are physically connected on the upper right. Okay, there. And we say that those lines that you see there connecting every little dot, you can think of them as galaxies. You can think of them as atoms. It doesn't really matter. We're saying that it looks like what you see at the bottom left, which is two atoms connected by a rope-like entity. That's the architecture of what connects two atoms. And now, yeah, we can talk about pull, we can talk about tension, we can talk about a lot of stuff that doesn't involve push. Okay? What we have there is connection, physical connection. Now we can explain gravity very easily. We don't need to talk about particles flying back and forth, and we don't need to talk about, dark energy pushing against the pull of dark matter or any nonsense of that nature. Okay, so that's the issue. The issue is that once you connect all the dots, you're done. That's it. That's all we needed to figure out, that there are invisible, intangible mediators, elongated mediators that connect every atom. We're done. That's how simple it is. Okay, and now, yeah, we can explain gravity very easily. Here's an astronaut falling to Earth. I've shown this several times. Let's show it one more time. As he falls, all these interconnections, these physical interconnections, they fan out. Okay, so they're not on the same axis. You can imagine this astronaut at infinity, far, far away from the Earth. All those what we call ropes, electromagnetic ropes, come together and form a single axis, a single coaxial. And as he approaches the Earth, they all fan out, and that explains the acceleration of gravity. Why you fall faster and faster and faster the closer you are to the center of a celestial object. Okay, so we're done. We can explain gravity with these ropes because the only issue here is that you cannot see or touch them. They are invisible, intangible, and that's what threw everybody off throughout the centuries. Okay, so the other issue that we need to answer, and that is that, gravity goes through things. You can't protect yourself against gravity. If you're falling from an airplane, you can't open your umbrella below you and say, oh, the umbrella is going to protect me. No, the umbrella is going to fall together with you. Okay, you cannot put a shield or something below you and say, I'm protected against gravity. No such monster. Why? Because gravity goes right through things, as Mr. Muller said. The funny thing, the strange thing about gravity is it goes right through things, meaning it goes right through an atom. Whatever you postulate, whatever your assumption is, it has to go through the atoms, okay? So the atom behind another atom, gravity goes right through them. That's what you got to explain. The only way you can explain that is if these connectors, these elongated physical mediators, they are, attached to all these atoms, and they go right through them, right? And here's I'm going to try to illustrate this. Here it is, okay? Here you have these atoms on the left, 1, 2, 3, 4, 5, 6, 7, 8. And 3 of them belong to the sun, 2 of them to the earth, and 3 to the moon, okay? Now, let's say they're aligned, okay? They're on the same axis for a split second, of a gazillionth of a second, right? And they're all on the same axis, okay? So when they're on the same axis, the only thing that, for this set, the pull is only between atom 1 and 8. That's it. All the others, 2, 3, 4, 5, 6, and 7, they don't exist as far as the universe is concerned for that axis, okay? So you have just a tug of war between 1 and 8. There's a tension between those two, momentarily, Now, as the Earth passes, for example, right, which is the frames on the right there, you can see that number 4 and 5 are not on the same axis anymore. Now, for the first time, those two atoms are noticed by the 1, 2, and 3, and 6, 7, and 8. Suddenly, it's like this, like a rubber band, right? You can pull on it, and all you feel is your fingers. You feel the tension there. You feel some kind of pull, right? But what happens? You ask someone to hold the middle, just to hold it, not to do anything, not to pull, because he can't pull on both fingers at the same time. He can't pull on the left finger at the same time as he pulls on the right finger. He pulls on one or the other. He can't pull on both. So if he just holds it, right? If he just holds it, that you won't feel that person. These two fingers won't feel that person. They will continue to feel each finger. That's it. That's all they will feel. They won't feel the fingers of the person who just touched that. But what happens when you pull it out of alignment? Okay? Now, these two fingers, this one and this one, right? The center fingers, they will feel the pull of the person pulling on the thumb, right? Because now they're not on the same axis. And that's what I'm illustrating there. I'm saying that, gravity works like that. Mass works like that. You're only going to feel the mass, right? If the atoms go out of alignment, go out of that axis. And that explains gravity in a nutshell, right? We do have a mechanism. It was baby stuff, kid stuff. The only issue, the only one that stumped all these mathematicians for hundreds and thousands of years is that they cannot see or touch the mediators, the elongated mediators. With that, I'll see you next week. Bye-bye.